problem. Okay. Okay, we're going to start. Just a quick introduction to this session. In this session, we will be showing 3 presentations. The theme of these presentations is trying to develop system engineering methodologies supported by ontologies and also having custom viewpoints. It's usually not very hard to have an ontological environment where you can directly model in the ontologies using like a text editor. But it's a completely different level if you're trying to make this accessible to end users who may not have the experience working with ontologies directly. So to address this challenge, we usually give them higher level viewpoints that would abstract away the ontological details and would also walk them through a method of constructing the models. So the work I will be starting, I will be talking about first, is an attempt to lower the bar for defining ontological methodologies with viewpoints. And in this case, where I will be showing how one could realize this vision in a tool called Obsidian, which is a note-taking application. And the next presentation will get into a bit more detail of actually using this tooling to define a methodology called Sierra, which is for system engineering. It's a new methodology under development. And lastly, there will be also a talk about how also such tooling is envisioned to be used to define another methodology by Leonardo. So I will be starting off with the talk about the general vision of how a tool like Obsidian, a note-taking app, a popular one, can actually be used to develop ontologies. So the OpenCSA project defines a core language called the Ontological Modeling Language, OML. This language allows users to define 2 kinds of models: vocabularies, which are the terminology of a business domain, and then description, which is a way to use that vocabulary to actually specify the details of a system. So if I give a vocabulary to system engineer and I told them, okay, go ahead and create a system model, and here is the vocabulary you can use, it will be a bit hard for them to know how to get started with this. What's the first step I need to do? How should I think about it? So this is the role filled by a methodology. A methodology kind of, it walks the modeler into steps that they have to follow in order to construct the model. And you want to do this with a bit of a high-level focused viewpoint, UI, that makes it a bit easy for the user to get started. So the OpenCSA framework with the Rosetta workbench, Eclipse-based workbench, allows you to do that. So this is, for example, how an OML model using just a text editor will look like. It has a grammar. So if you're familiar with the grammar, on the left you can define a vocabulary as a bunch of concepts, properties, and relationships. And then on the right-hand side, you create your actual system model, declaring what vocabularies you want to use, and then you start creating instances and statements about these instances. I have a component, I have a subsystem, the mass is like this, the power is like that, and so forth. You could also use a visual notation like a diagram. It could make it a bit easier. However, a box and line kind of notation will be useful for like a vocabulary. You can look at it as like a class diagram. But for the system model, if you looked at it as just like a boxes and lines, like what in UML may be called an object diagram, it will be a bit hard to understand what's going on. You would rather have a more curated viewpoint to work with. And currently, the OpenCSA project provides a workbench called Rosetta, Eclipse-based workbench, that allows one to define such high-level user interface. Just to give you an idea what this looks like, this is a video that shows how such environment could look like. For example, this is what we developed at JPL for one of our domains. It's a user interface that shows a system and subsystem modeling. You can see a tabular view that lists all the subsystems and the components in them, and some of the important fields as columns. But you can see also at the bottom a view that shows the more elaborate properties that you could specify for these objects. So this is the kind of user interface a user can work with. And under the hood, what's happening is an ontology is being created using the vocabulary that we chose in this case. So this is kind of the user experience, or I would say the system engineer view of ontological modeling will still look like a viewpoint like that. And we are using here a declarative framework that allows us to put out these user interfaces. And that has served us well so far. We have been deploying tools using Eclipse for some time. However, our users, and with the advent of the web frameworks, are asking for more web-friendly viewpoints. So this is what led us to look at maybe other solutions to this. Lost my mouse for some reason. Happened to the mouse. Oh, here we go. Sorry. Okay. Just give me a second to recover from that. Okay. Can you see my screen? Yes. All right. So the next thing after Eclipse is we ventured into VS Code. It's another framework developed with web technology. So that felt like a good alternative to go and build these frameworks on. And we started actually a project called OML Vision that's meant to pursue that path. However, what we realized is that it still requires significant development effort to develop these viewpoints on top of the OML language using that. We would basically need to build first a framework to defining these viewpoints and then use them to realize a particular viewpoint. So The motivation of us looking to some other environment was we wanted to lower the bar, make it easy for methodologists to put together a viewpoint over their vocabulary and release it to their users to work with. We looked for options and we arrived at a very neat technology using actually Markdown format. It's a very popular web format. But interestingly, a Markdown file can actually play two roles. It can allow you to have an informal description, like a document-like view, so you can add informal information about your model, but it also has a YAML section at the top called the front matter that actually allows us to capture well-structured ontological information following a vocabulary. So Obsidian is a popular note-taking application that takes this idea of Markdown having informal and formal structure to the next level, allowing you to create an immersive experience with Markdown, creating templates for your notes, representing viewpoints that one could design for their methodology. So to just give you an idea, a Markdown file will look like what you see on the right-hand side. It has this at the top, this section called front matter, which is a set of like attributes that you could provide values for. And then after this section, you can have just text and media and something called code blocks, which are dynamic section of your Markdown that can be executed and have a user interface. So when one can write a Markdown like this and then go into render mode, the view could look like what you see on the left-hand side. It can look at it will look like a viewpoint. For example, here you're looking at a definition of an activity that has a description field. It has a list of sub-activities, a list of super activities, and then some diagram that visualizes what you did. And what you see here is just encoded using what you see on the right-hand side. And so it becomes very accessible for one to define a template for what's on the right-hand side and give it to the user to create what's on the left-hand side, including to add more activities, to add more sub-activities, super activities, and to keep the view in sync with these automated diagrams. So basically, Obsidian, of course, out of the box, doesn't know anything about modeling or system engineering or MVC or anything. But what we did is we took the idioms that are available in Obsidian, and we made them work into a viewpoint definition mechanism. And that's what I wanted to show you today. So for example, we in OpenCaesar, always the starting point of doing anything is defining a vocabulary. So if you define a vocabulary, which is a set of classes and properties and relationships and constraints, how can we go from that into a viewpoint definition like Markdown based, as you saw in Obsidian? We developed an adapter to do this. An adapter is an interface that takes one model and creates another. So in this case, we took the vocabulary model from OML and we produced an Obsidian template from it. That Obsidian template will have as much information as we can from the vocabulary itself. So all this YAML part at the top, which what are the attributes that are allowed, what are the domains and ranges and cardinality. All of this is intact. What the user has to do extra is to specify these viewpoints, like the UI, the parts where how you want to structure the document into sections, and which parts will be dynamic, which parts will the user be filling in. So luckily, Obsidian has this extension called metadata menu that allows you to look at a markdown file as a model element. Already, you can define classes and you can define attributes. So we took advantage of this by, in our adapter, we basically generate all the metadata required by this extension to have a realization of the vocabulary within Obsidian. So I want to show you this slide here, where typically in OpenCaesar, you start defining a methodology with a bunch of vocabularies, and then you put them into a bundle. A bundle is like a group of vocabularies that belong together or work together as a set. We developed this interface, OML to Obsidian, that takes that and generates the metadata for the Obsidian. That turns into two kinds of artifacts. Class definitions using this metadata extension allow us to create all these class definitions. And then we use the regular templating in Obsidian to create markdowns that uses that class. And the idea is, once you do this, then your system engineer can start creating the model by instantiating these templates. And these instances will have a combination of formal information in the YAML section and also informal information, which is interesting because typically engineers are used to creating documents, right? And we are trying to get them to create models instead. So instead of asking them to completely forego the documents and completely go to model, this allows a transition. It allows them to still manage to specify some information informally, but also start capturing more and more formal information in that YAML section. And the idea is that once they do this, we can develop a reverse transformation that takes the instances, the markdowns they created with the YAML, and convert them back into ontology, pure ontologies that we can reason on.
Good.
Yeah.
I have a question about that.
Sure.
So if I'm the systems engineer and I'm working in the Obsidian Vault metadata view and working with the templates to create my instances, I think is how this proposed to work, right?
In the metadata, you create the viewpoints.
Yeah.
And then as a system engineer, you create the instances.
Okay.
Here.
So it may not be, it's not something here that's one thing that I at some point would want to see is that it assumes that all of the vocabulary is correct. Now systems engineers are going to find, they're going to find the space between the discrete bins for things. So if you have your model has bin A and bin B, they will find the 7 in between those two and say, why isn't there a 7 between A and B? Makes no logical sense, but it needs to be there. So as far as feeding back to the vocabulary bundle to update that, is there any process or part of this plan to account for changes to the model as the systems engineers work on it?
To change the vocabulary
Yes.
as insights are gained.
Yes. Well,
with practitioners.
You're assuming there's a looking forward. You've got a bunch of smart people. They said we've done spacecraft before.
Yeah.
We know how to develop this vocabulary. The systems engineers in doing that stuff I was saying earlier to Steve about messiness.
Yeah.
They will find the in-betweens.
Right.
And as long as there's a mechanism to feed that back into the formalism,
yes,
I think you will find the working systems engineer to be a lot more. We can tell them, we can hit them with the hammer and say, no, that's wrong. You do it this way. That's not a very good way of doing it. So I just want to, at some point, the modifiability of the vocabulary bundle in response to the work being done in the instances, that's a plan.
Yes, so the workflow is when such insights are gained by the practice and on the right-hand side, that will turn into changes to the vocabulary bundle. Those changes might be breaking or non-breaking. If changes are breaking, i.e., they will make what the engineers did, we can refactor their information to comply with the new version of the template.
Okay.
Can I add to that?
Yeah.
Yes, we can refactor the vocabulary, and we're always looking at trying to capture everything, but we will never capture everything model. At least this methodology allows the system engineer to say what they want to say in the text, and we've captured it in the model. Used to capturing all kinds of details in documentation.
Yep.
At least it's there. Okay. People can see it.
I would say one person that captures it one way may represent 5 or 6 other people that see it the same way. And so as far as
This is an incremental improvement.
yeah,
right?
and so it's absolutely, I'm just thinking for the future going forward is the ability to find and adjust the model going forward to new understanding as the work gets done will help to grow that definition.
Yeah, and absolutely. And as a new methodology is developed, it will have to experience this feedback loop where people are giving that changes the vocabulary, in turn changes the template, and we need to adapt the current data to the new template and so forth until it stabilizes at some point. Yeah, okay. So I just want to show you quickly how this looks like in Obsidian. Here is a one of the vaults, and it has this methodology called Sierra. And I don't know why my mouse is spinning, but okay. So you can click. It will tell you, okay, the Sierra method has these kinds of viewpoints to it. And then it will tell you, okay, for example, you can start with operational analysis. So you follow the link, and then it will tell you, okay, to do operational analysis, you need to do these steps, or you can do these kind of activities. So you can, as you can see, you can establish guidance to the engineers of what kind of things I can do now. So for example, it says I didn't create a mission. So it takes you to another screen. Now I want to create a mission. So I click this button. I say, okay, for example, Mars sample return is my mission. And it will create the mission, and this diagram will keep up to date as you are creating things in this vault. So here I'm going into the Mars sample return. I see now there's a template to fill, description. This is the Mars sample return mission. So this is just pure markdown. So I can go and, for example, want to drag this here. And you can create what you may be used to in a markdown, very informal. However, you can also have formal sections. For example, what activities are in the mission. So you can start creating activity 1, for example. And as you can see, creating activity 1 is possible because in this vocabulary, a mission can own activities. And then when you go to an activity, again, you can have another template for activities. And as you can see, an activity may have some requirements that is driving it. You can parameterize it. You can set goals. You can have preconditions. And a lot of these concepts are coming straight from the vocabulary itself. So once you define the vocabulary, all your template will keep that structure, but also give you the ability to write as you need, completely free-form, text-based, markdown-based information. So this achieves that it lets the user maybe not completely depart the documents, still keep an aspect of that while encouraging them more and more to fill the information based on a known vocabulary or a known template their team is working with. Of course, the goal is to then take the information, the vault they created, and convert it back into ontologies so that you can continue to analyze it in an ontological way. Run reasoner on it, invoke notebooks that calculate all sorts of things, interface to analysis tools. Everything is still intact. We are just lowering the bar in the authoring experience, and it's lowering the bar for both the methodologists. It's very easy now to create viewpoints in such a format, and also it's easy for the end user, the system engineers, in using these viewpoints. And the nice thing about this also is that all the view definition are files, which means they can be stored in Git in the same repo as your data. So this means in a single repo, you can have the data and the metadata version control together. And as you evolve, you can do this. This is as compared to the release process in Eclipse, for example, where your tooling is like a plugin that you have to deploy, and it's a bit more involved than having to manage this information in this fashion. So
Is Git integrated into the Obsidian tool?
It is integrated absolutely into the Obsidian tool. There is a Git perspective.
All right, thanks.
Yep. So it's still like early experimental work, but it's very promising. We are developing Sierra as the first phase as an activity modeling tool, and we are giving it to people doing ConOps. So in the very early phases of a mission, you capture your what are you planning to do in the mission activities, and you are also trying to put together scenarios for those activities.
I'll just comment on that.
Yeah.
Just like have it go to the people that are in phase C and D and see how they look with the ConOps and how those change, because that will make a big difference. They'll have some inputs,
Yeah,
as well as the phase A people.
absolutely.
They'll
So
be very different.
we noticed a disconnect between the model, the ConOp, which is now a document at the beginning, and it gets forgotten until the later phases when they have to recreate the information in some sort of formal way to do the testing. Our plan is to make it a model and make it actually the driver for the analysis and testing throughout the life cycle. So just to conclude, so the example I showed you started with a vocabulary that looks like this. I'm defining activities. A mission is a kind of activity. It can nest other activities. And then I can create activity calls in scenarios. So I can create the scenario where these activities are being called, and they can be constrained in different ways and be given objectives to achieve.
Okay, really question, just language. Sierra is
Here
what?
is the name of the vocabulary
Okay,
that we are developing here for ConOps.
I see. Okay, thanks. Okay.
Yeah,
All right.
just a name. So we generate from that the Obsidian metadata, what you saw in my demo here, and these are the screens that a methodologist can then very easily define with Markdown to make it easy for the system engineers to go and fill in the information needed. And then finally, there will be that reverse transformation that gets you from that vault of Markdown files back into ontologies. So this is what will be something we will be working on, is to do the reverse Obsidian back to OML. And we will be evolving the Sierra method as a ConOps, a modeling methodology, and maybe it will latch to the other like areas we do downstream into one integrated methodology. That's the vision anyway. All right, I think I'm done with this presentation. Is there any question